How can we implement a contacts list in code? The key feature of a contacts list is being able to look up a phone number by a person's name. You could technically do this with variables. For example, to store Henry's number, you could assign it to a variable called phone number for Henry. To store Mary's number, you create another variable like phone number our number. Whenever you need someone's number, you just print that variable, but the problem is that this quickly gets messy. As the number of people grows, phone numbers end up scattered everywhere. So we need a data structure that can store all phone numbers in one unified place. What about using a list, which we learned earlier? If we use a list, we do end up with something that looks like a contacts list. But a list of phone numbers alone doesn't tell us who each number belongs to. That completely defeats the basic purpose of a contacts list, looking up numbers by name. What we really want is to bind names and phone numbers together. This is exactly what dictionaries can help us do. A dictionary is used to store key-value pairs. The key is called a key, and the corresponding data is called a value. Each key maps to a value, and we use the key to look up that value. This works just like a real-world dictionary. You look up a word as the key and get its definition as the value. An empty dictionary is represented by a pair of curly braces. To store multiple key-value pairs, you put them inside curly braces, connect keys and values with a colon, and separate pairs with commas. To get the value for a specific key, write the dictionary name followed by square brackets containing the key. One important rule is that dictionary keys must be immutable. Lists are mutable, so they cannot be used as dictionary keys, strings, integers, and floats. On the other hand, work just fine. But what if your contacts list has 3 people all named Mike, and you need both name and age to tell them apart? Lists can't be keys, so what do? Python thoughtfully provides a data structure that's immutable, but looks a lot like a list, the tuple. Tuples can hold multiple elements too. Visually, lists use square brackets, while tuples use parentheses. Because tuples are immutable, you can't add or remove elements from them. That lack of flexibility is exactly what allows us to store multiple Mike entries in a dictionary. In this case, those tuples become the dictionary keys. When looking up a phone number, you use the entire tuple as the key. Like lists, dictionaries are mutable, so you can add and remove key-value pairs. For example, if you get a phone number from someone new and want to add it to your contacts, you can assign a phone number to a new key using square brackets. This adds a brand new key-value pair to the dictionary. But be careful updating a value uses the exact same syntax. If the key already exists, this operation will overwrite the original value. You gain a number, but you also lose the old one. If you want to check whether a key exists, you can use key in dictionary, which returns a boolean. It returns true if the key exists and false otherwise. To delete a key-value pair, you can use del. Write del followed by the dictionary name and the key in square brackets to remove both the key and its value. If the key doesn't exist, Python will raise an error. If you want to know how many entries a dictionary has, the good old lend function still works. And now, it's time to practice. We can create an electronic dictionary for looking up internet slang and popular phrases using a dictionary. This exercise will combine dictionaries with previously learned to input and do full statement, input and die full statements. You can search for some English slang terms online. First, create an empty dictionary. We can pre-populate the dictionary with 2 entries. The method is key, followed by the corresponding value. For example, I'll add the entries for goat and sleigh. Separate the next key-value pair with a comma, and it is recommended to break the line for clarity since it is a bit long. After line breaks, each entry will be clearer. Now we've created a dictionary with a length of 2. Then, add the following slang terms and their definitions to the dictionary one by one. You can search for more, such as cap, based, sus. The way to add them is dictionary name, square brackets, put the key inside, and assign a value to it. Now our dictionary has 5 entries. Adding them one by one is a bit slow, so I'll use some editing magic. Alright, now my dictionary has 10 entries, and we can start implementing the lookup feature. Our lookup feature works like this. First, Ask the user, please enter the slang term you want to look up. Also, remember to assign it to a variable, such as binary, otherwise we won't be able to capture the user's input. We need to know if the queried term exists in our dictionary. Here, we use FindMate to check. If the key is in the dictionary, first print it for the user. Print a line like, the meaning of query is as follows. Then, we print the meaning of the term for the user. How do we get the definition of toguri? It is the dictionary name, square brackets, and the key name. But here, we have a variable, so we put toguri inside. This is equivalent to using the user's input to look up its corresponding value in the dictionary. If the queried term is not in the dictionary, we first print for the user. Sorry, the slang term you queried is not yet included. Then, we inform the user how many entries are currently in our dictionary. Here, a reminder, we need to use the vilen function. Currently, this dictionary contains entries. To get the length of the dictionary, use vilen with the dictionary name inside. But note that vilen returns an integer, so we need to convert it to a string in order to concatenate it with a previous string. Let's say I want to look up the meaning of goat. You can see it successfully prints the meaning of goat, because I have that entry. Now, let's try a non-existent slang term, like ASDF. You can see it also tells me, sorry, the slang term you queried is not yet included. And it successfully prints how many entries are currently in the dictionary.